The 2020 Atlantic hurricane season was like no other. We haven't got time to go through every record it broke because there were just so many storms, exceeding all forecast expectations. Not only a record total of storms, but the majority being the earliest on record for their number. These are the storms that developed just during the month of September, a record 10 in total. And in September, the list of pre-planned storm names ran out, which meant meteorologists had to start using the Greek alphabet for only the second time to find new storm names. Hurricane Eta, which hit Central America in November, was a record-tying 28th named storm of the season, bringing severe flooding here to Honduras and to Guatemala, where more than 150 people died in floods and landslides. After, Storm Theta took the season to a record 29 storms. Central America was in the eye of a hurricane again, as Iota became only the second maximum Category 5 storm ever recorded in November. And although it weakened slightly before making landfall in Nicaragua, the destruction it wrought was widespread and devastating.
There it goes. Oh.
And of the 12 storms to hit the USA, Hurricane Laura in August was the strongest in the state of Louisiana in at least 160 years. So, what's the weather science that can explain such an active hurricane season? That's a question I put to Dr. Jennifer Collins, a professor of geosciences at the University of South Florida.
First of all, we have to look at some of the large-scale time circulations that have been going on. So the Atlantic multi-decadal oscillation, this is in a positive phase. It has been since about 1995, and a positive phase of the AMO tends to bring warmer sea surface temperatures, which are conducive for hurricanes. And so we have this positive phase of the AMO, but superimposed on that, what's going on this year is we also have a moderate La Nina.
We'll be talking more about La Nina later in the programme, but what is its influence on hurricanes?
Well, when you have La Nina, you tend to get weaker upper level winds, we tend to get lower wind shear because of that, and that's conducive for these hurricanes to form. So with warm sea surface temperatures that we've had this year, lower vertical wind shear, that's really provided like the right breeding grounds to provide this record-breaking hurricane season.
Is it possible to say with any certainty what effect climate change may be having on hurricanes?
When we talk about climate change, is actually strongest when we're attributing types of extreme events such as heat wave that are more closely connected to human-caused global temperature increases. Confidence tends to be lower with some other type of events such as hurricanes. As you can imagine, with global warming, we're seeing glaciers and ice sheets melting, and as they melt, the sea levels rise. Well, when a hurricane's strong wind pushes that water onshore as storm surge, this results in even greater flooding. So we are already seeing impacts of climate change and global warming on hurricane impacts.
Jennifer Collins, thank you. Now, on the other side of the world from that record-breaking Atlantic storm season, similarly intense storms in the Western Pacific Ocean are known as typhoons. And in 2020, in contrast to the Atlantic, the Pacific has been quieter than average. The season started late, had a record quiet July, and has been unusually overshadowed by the number of Atlantic storms. That said, the season roared into life in October, with 5 storms going into Vietnam, bringing huge rainfall totals and widespread flooding. And also in October, Super Typhoon Goni hit the Philippines with such intensity it now holds the record for the strongest to make landfall there. But in contrast to what we've seen in the Atlantic, it's thought stronger wind shear through the atmosphere helped to limit the overall number of Pacific storms in 2020.